Welcome to video on order of operations. So we're going to talk a little bit about the acronym PEMDAS, P-E-M-D-A-S. So what it stands for, the P stands for parentheses or grouping symbols. Parenthesis. And you could also write in there that they're grouping symbols. They can be parentheses. You have a left parenthesis and a right parenthesis, but you could also use brackets. It just groups terms of an expression together. So grouping symbols. P stands for parentheses. Grouping symbols. E is for exponents, and PEMDAS is order of operations. We do parentheses first. Operations that are inside of parentheses, we do those first. And then we do exponents. Okay, let's remind you what exponents look like. If we have x and then the 2 up there, that 2 is called the exponent. It's the power. And remember, that means x times x. So parentheses are a way of writing multiplication often. 4 to the third power, that would mean 4 times 4 times 4. Okay, so remember what exponents mean. That's going to be helpful in this section. Okay. M stands for multiply or multiplication. And multiplication, we can use a dot for multiply. We'll see that down below. In fact, let me scroll a little bit. See that dot right there? That's multiply. Okay, that's multiplication. We sometimes use the X for multiplication symbol, but we won't do that much in secondary math 2. And then we have this. Just to remind you, if I have 2 and y stuck right next to each other with no symbol in between them, that means multiplication. It's 2 times y. We call y the variable, and in this case, it's 2 times y. So there's multiplication there. D is divide or division. And we can use a division symbol like that. Or we can use a division symbol like this. Or maybe we write it as a fraction. 3 divided by 4. That's a fraction is division. So 3 divided by 4. So think about those things as you go through this section. A is for add or addition. And we'll use the plus sign for addition. S is for subtract or subtraction. And then, of course, our subtraction symbols like that. And it looks like that in order of operations, we have 6 steps, but we really only have 4. Because multiplication and division are on the same level. We're going to lump those together. So multiply and divide go together, and add and subtract go together. So as we number the steps, the first step is you do the parentheses, operations inside parentheses. Then you do exponents. Then you do multiply and divide. And then last, you do add and subtract. I also want to mention that the multiply and divide part of PEMDAS and the add and subtract part of PEMDAS, if parentheses are all done and you have several, let's say, multiply and divide, you do those left to right when there are no parentheses. Okay, but we'll do the multiplying and dividing before we do the adding and subtracting. So on these, we do them left to right. Left to right when there are no parentheses. When there are no grouping symbols. Okay, and we're going to dive into some examples. We have 6 of them here, and then we're going to do some plugging in. So example 1, evaluate, which means simplify or find the value. So we're going to go with PEMDAS, and PEMDAS says we need to do the operation inside the parentheses first. So we're going to add the 5 and the 3. So we're going to add here. So we're going to do 4 times 8. 5 plus 3 is 8. And then the 4 times the 8 is 32. It will be very helpful if you know your multiplication facts. And then the last thing we're going to do here is the adding. So we've got the multiplying taken care of. 4 times 8 is 32. Then we'll do the addition. Notice the order we did these in. So focus on the order. We did the parentheses. There were no exponents. Then we did the multiplication and then the addition last. All right, example 2. Notice the 3. That's an exponent. That is what we call an exponent. So that 3 is an exponent. An exponent of 3, which means we have 2 times 2 times 2. We need to do the exponent before we do the multiplication that's in the middle. Analyze the structure of the expression. It will help. Okay? So we're going to do the exponent first. And what is 2 to the 3rd power? It's 2 times 2 times 2. 2 times 2 is 4, times another 2 is 8. So we have 5 times 8. And that is going to give us an answer of 40. All right, example 3. Analyze the structure. Notice I have a division, and I have an addition. So before we do the adding, we have to do the dividing because that's order of operations. The multiplying and dividing come before the adding and the subtracting. So we'll do the 12 divided by 6, which is 2. We'll do the 4 divided by 2, which is also 2. And our final answer will be 2 plus 2 is 4. So there's our final answer of 4. All right. Example 4. We're going to do the operations inside the parentheses. Now be careful. We can also do this out in front. We've got a division. We'll do the addition last. We can rewrite this as 8 divided by 4. 2 times 2 is 4. Plus, let's work inside the parentheses. We have to do the squaring first. Notice that exponent right there. It's a power of 2. 5 squared is 5 times 5. We'll just write that off to the side here. 5 squared is 5 times 5. And 5 times 5 is 25. So I'm going to have 6 times 25. Oops, not a parenthesis yet. There's a plus 3 in there. Notice I use the dot for multiply again. And then plus 3. So we have to do the multiplying. So we're going to rewrite this 6 times 25 is 150. And then 150 plus 3 is 153. 8 divided by 4 is 2. We've got 2 plus 153. We've got 155 for our answer there. Okay. Should add a little more space for that one. Example 5. We're going to do some simplifying here. We've got an exponent that we need to take care of. Now you have to be really careful with this one. Notice these parentheses right here. They're grouping the negative with the 3. So we're not just squaring the 3, we're squaring the negative 3. So we're going to have negative 3 times negative 3. Let's think about that. Negative times negative turns into a positive, and 3 times 3 is 9. So negative 3 squared turns into a 9. Negative 3 times negative 3 is positive 9. Then we're going to have 0 times 8, which is 0. And out here on the back, we're going to have 8 divided by 4, which is 2. All right. 4 times 9 is 36. The 0 will disappear because 36 divided by 0 is still 36, but we have to add a 2 to that 36. So our answer becomes 38. Another 38. Okay, example 6. Last one of these examples. So we have 3 times 3 plus 7. So we'll do the stuff in the parentheses first. The operation there is addition. 3 plus 7 is 10. And I have a subtraction sign. Because I have that subtraction separating them, I can go ahead and do the exponent in that next expression right here. 10 squared is 100 because that's 10 times 10. And I've got 100 divided by 2, which is going to turn into a 50. That 3 times 10 is going to be a 30. 100 divided by 2 is 50. And what we will then have is 30 take away 50. We're in the negatives. We can do 50 take away 30 and just stick a negative sign on the front. Negative 20. All right, when evaluating an algebraic expression, we first, we're going to plug the value for each variable, plug in or substitute. I want you to look down at the examples that we're doing. It says evaluate x squared plus x minus 3 for x equals 2. What that means is we're being asked to substitute or replace the x with a 2 and simplify it. So when you're evaluating an algebraic expression, we first substitute the value for each variable. If you look at example 8, we have 2 variables, x and y, and we're going to substitute in for the x and the y. In example 9, we have 3 variables, a, b, and c, and we're going to substitute in for the a, the b, and the c. So we substitute in the values for each variable, and then we follow the order of operations. And we'll be doing quite a bit of that this year. Okay, now, don't want to reboot right now. Example 7, evaluate x squared plus x minus 3 for x equals 2. What we're being asked to do is just replace the x with a 2. I like to put parentheses around my variable value when it's inside of an exponent because those parentheses can make a difference. So I've got 2 squared plus 2 minus 3. So we plug in or substitute the 2 for the x, and then we need to follow order of operations. Well, 2 squared, I got to do that exponent. 2 squared is 2 times 2, which is 4. And then we're going to add 2, and we're going to subtract 3. And we're going to work left to right, since we don't have any other grouping symbols, no more parentheses. 4 plus 2 is 6. 6 take away 3 is 3. So our answer is 3. Example 8. Evaluate the expression 3x squared divided by 12 plus y for x equals 4 and y equals negative 7. Now I want you to notice something about this. 3 over 12 will reduce. So there's going to be some reducing here. If you don't notice that, it's okay, but it would make life easier. So we're going to replace the x with a 4. We're just replacing at that point. And we're going to replace the y with the negative 7. So we're going to do plus negative 7. Now remember, adding a negative is the same as subtracting. So in the next step, I'm going to change that to subtracting. Now notice what I have. I'm going to write this out. 4 squared is 4 times 4. So I have 3 times 4 times 4 divided by 12. And adding a negative is the same as subtracting. So I've got to subtract 7. Now what I have is a 12 over a 12. So those will actually reduce. Or you can multiply it all out and you get 48 over 12. But 48 divided by 12 is 4. Okay? So it's like reducing fractions. We can take out those common factors. 3 times 4 is 12. We can just reduce that. We get 4 take away 7, which is negative 3. And we're done. Okay, last example. We're going to take b squared minus 4ac and evaluate it when a is 3, b is -1, and c is -5. So we're going to be really careful here to make sure we get the variables in the right place. B is -1, so we're going to replace the b with -1. Notice the parentheses. They're super important. The -1 is squared, not just the 1, but the -1, and it matters. Subtract 4 times a times c. Notice how I'm using the parentheses to indicate the multiplication. Parentheses have lots of roles in mathematics. Okay, so let's now simplify following order of operations. So I'm going to do the squaring first. -1 times -1 is +1. Negative times negative is positive, and 1 times 1 is 1. Now I'm subtracting, and I'm going to do 4 times 3 times -5. So it's not -4 times 3 times -5. If I did that, I'd have to change it to a plus. So I'm going to have 4 times 3, which is 12. 12 times -5 is -60. So I have 1 minus -60. Notice what I said? It changes to a plus, because subtracting negative is the same as adding. We could also do it this way. Look at it this way. You can do -4 times 3 times -5. You have a negative times a positive, which is negative, times another negative makes it positive. So you can play games with the signs of the numbers that way as well. Okay, my eraser doesn't seem to want to work here. Let's see if I can get it to go. It doesn't look like it. Okay, well, we'll just do 1 plus 60 and get 61 for our answer and call it good. And we're done.